Okay, copy down this one. Okay, finished. 1 more minute. Okay, let's continue. Okay, next we look at the frequency of sound wave. Let's take the same example, the tuning fork. Now, if you remember just now, I said that when you strike this tuning fork, it produces a certain pitch. Okay, no matter how you strike it, it will keep on the same pitch. Okay, it will keep producing the same pitch and the same notes. Okay, and in the musical language, right, this is note A. Okay, note A. So now I want you to think of frequency as pitch, right? Anything vibrates at a certain frequency. Okay, so you can say that anything that it vibrates at certain pitch. Okay, so let's say I strike this tuning fork. Okay, now it generally will vibrate at 440 hertz, right? So you're familiar, if you're familiar with this unit, hertz, Hz. This stands for frequency, right? Gigahertz, megahertz, all this frequency, right? So frequency is pitch in the context of sound. In the context of sound wave, it means pitch, right? So 440 hertz, there's a certain pitch. And let's say if you increase this frequency to like 500 hertz, and then the pitch change, right? The higher the frequency, high frequency, the higher the pitch, right? The higher the frequency, the higher the pitch. So if low frequency, low pitch. So change in pitch is equivalent to change in frequency, right? Now, let me give you a more technical definition of frequency. Okay, now frequency, the real definition, the real meaning of frequency is the number of vibrations in 1 second. Okay, now bear with me first. You just write this down. Frequency is equals to the number of vibrations in 1 second. What does that mean? Now let's talk about vibrations. How does the particle vibrate? Again, we are talking about sound wave, right? We are talking about sound wave. So how does the particle vibrate? Up and down or back and forth? Is back and forth, right? Because sound wave is a longitudinal wave. So let's say this is the particles. Okay, let's take only one single particle just to see it clearly. Just one single particle here. This green guy. Right. Same, we take 3 positions. First is A, second is a distance from A, B, and third position also. Okay, C and B must be the same distance here. Distance, and this one, the distance D1 and D2, same. Okay, now, how does the particle vibrate? It moves to B first, and then from B it moves to C, and then all the way back to the original position. Now this one, we call it one vibration. Again, I repeat, particle moves from A to B, and then from B to C, and then from C to back to A. This one we call one vibration. Or in other terms, you can call it one oscillation. Sometimes you will see this word. Okay, one complete vibration is just like one cycle. Okay, it's just like one cycle. From original position and then come back to the original position, one cycle. Now, this is one vibration. So if you look at frequency, it is the number of vibrations in 1 second. So what does it mean? If you look at this 440 hertz, what does it mean? 440 hertz, meaning that this tuning fork, it is vibrating as you strike it. It is vibrating at 440 vibrations in 1 second. You just imagine the particles in the tuning fork. It repeats this same process from A to B, from B to C, from C to A, 440 times in just 1 second. Is it fast? Yes, it's fast, right? It's very fast, right? So frequency equals to what? Pitch. And what does it mean? It means the number of vibrations in 1 second.
No, sir.
Yes?
Pitch, is it like 极高音 like that?
Yeah, 极高音，对，极高音。So 如果你很高音，就是你的 pitch 很高，也就是讲你的 frequency 很高。OK？ 不同的 frequency， 不同的音调。440 Hz 跟460 Hz 一样音调吗？不一样啊，不一样 pitch。Alright? Now, okay, I forgot what I want to say already. Okay, so that's about oh yeah, okay. Let me draw this. Okay, you guys write down this one first. Write down this one first. 1 minute. Okay, let me erase this one. Okay, I just want to keep the diagram at the bottom there. Okay. Now, if I were to represent this vibration, this movement of particle in a wave, how does it look like? Let's draw the axis. This is our y-axis, and this is our x-axis, right? Can see, you cannot see, let me know, because I'm drawing at the top corner there. Okay, so y-axis and x-axis. So the wave looks like this. This is how we represent wave, mathematically, how we represent the wave. Okay, so this wave, at this point, the first point here is A. So it is starting at A, its original position. And at this point, at the top here, this is B, right? B. So if, yes, Amos, if it's 500 Hertz, then that is 500 vibrations per second. Okay, now so this is B, and here, the bottom is C, and ending back to A. This is when I want to represent this motion, this entire motion into a graph. So it looks like this. So it looks like a wave graph, right? Like a wave. If you have learned the sine, I'm not sure if you have learned this one in your maths. Sine x, cosine, and tangent. You should have learned this, right? Sine. So it looks like a sine graph. This is a sine graph. Sine graph, right? Sine looks like a wave. All right. Now this one is one. If you compare these two, particles move from A to B, B to C, and C to A. We call it one vibration, right? So let's look at the graph now. Look at the graph. Don't look at the diagram. The graph, particles start from A here, moves to B, up here, down to C, come back to A. So this one, we call it what? One vibration or one oscillation. Okay? So if
Teacher,
I say,
what is oscillation?
Yeah, what is it?
What is oscillation?
Vibration, same meaning. Vibration equals to oscillation.
Oh, okay.
Okay, same meaning. So when I talk about one vibration, straight away you should know that, okay, it looks like this, like a sine graph, one vibration. Okay, now if I draw like this, let me erase this. One, two. How many vibrations here? This one is counting from here, starting. This is one vibration until here, and this is another vibration here, right? Because you have two waves here. So this wave, this particular graph, tells you that there are two vibrations. Okay. Now, I erase this diagram here, bottom at the bottom, because I want to get some space here. Okay. Now you know how to identify number of vibrations from the graph, right? Now let's determine the frequency. If I give you a certain graph, you should know how to calculate the frequency. Okay, let's say I give you this graph. Okay, this graph shows typical sound wave, like 1, 2, this. Let's say this is like Okay, our y-axis here and our x-axis here, right? So x-axis is equal to the time axis. Time axis, and y-axis is the distance. Okay, so in general, y-axis means the distance. In wave, for all the waves graph, y-axis represent the distance, and x-axis represent the time. Okay, so let's say I put this one here, 2 seconds. The unit is second, SI unit, second. Can you tell me what is the frequency of this wave? Okay, what is the formula for frequency? Okay, what does it mean, frequency again? Frequency is the number of vibration in 1 second, right? Meaning that number of vibration divided by time. This is the formula for frequency. Okay, I repeat, number of vibration in 1 second means that number of vibration divided by time. Okay, now identify how many vibrations this graph has. There are 2 waves, right? Here, this is 1 vibration, and this is another one. So there are 2 vibrations. I just put 2 divided by time. So what is the time? Here, 2 vibrations in 2 seconds, right? Here, 2 seconds. So 2 vibrations in 2 seconds, 2 divided by 2, you get what? You get 1. So the frequency of this particular graph is 1 hertz.
Teacher,
Okay?
for frequency, the number of vibrations over time, does it have to be seconds or?
In second.
Oh, okay.
You mean the unit for time, is it?
Yeah.
Yeah, the unit for time is in second.
Then what would be the unit of frequency?
Hertz. This one, hertz.
So vibration would just be vibration.
Yeah, the vibration will just be the number of vibration. All right, the number of vibration, it has no unit. It's just how many times, how many vibrations are there. Right, so the unit for frequency is hertz. So whatever answer you get, you write the unit Hz. No need to write the word, just write Hz, 1 hertz. All right, so I'll give you another example. Okay, before that, you copy down this one first.
Teacher, just now the notes, right? You got right straight line vibration and then a slanting line oscillation. What does that mean?
Straight line vibration. Which one?
Just now the notes. You wrote a vertical line and then you wrote vibration and then you wrote a slanted line and then you wrote oscillation.
You mean the which one? I forgot already. Do you have the? You mean the?
You wrote it like this. Wait.
Can you draw on the board? Can you draw on the board?
You wrote a straight line like that, and then you wrote vibration next to it, and then you wrote, and then you did this. Wait. Yeah, and then you wrote oscillation.
Oh. Okay. That is like, I'm trying to say like vibration. You can write vibration or oscillation. Yeah, this one, same meaning. What I'm trying to say is, vibration is, in other terms, it is called oscillation. Because sometimes you don't see vibrations. Sometimes more commonly they use oscillation when you go to like the IGCSE okay stuff.
Teacher.
Yeah.
From what we get our GED.
Can you repeat? What is that?
At what age we get our GED?
GED, what is that?
GED is like the thing that you need to get before you go to college.
The thing that you want to get, like grade?
I think so, yeah, because like
I'm not sure
near my
about what you are. What is that stand for? Like GD? What is that? An exam or what? An exam or what? Maybe you type in the chat because I can barely hear you here.
general educational development.
I have no idea what is that. GED.
Oh, okay, never mind.
I've never heard of that.
Okay then.
Yeah, maybe you can just search up Google. What does it say? Okay, we have 20 minutes left. Time flies. Okay, finish this one. I erase. Okay. Wait, one more. Okay, this looks so messy. Do it again. Okay, look at the left diagram. Can you calculate the frequency for this? Okay, let's do it together. Frequency, I just write FREQ equals to number of vibration divided by time. Right. How many vibrations this one? Starting
3.
point. Here is A, here is A. So this is one vibration, one all the way to here. This is one. How about this one? At the back. A normal wave structure looks like this, right? Like this. Okay, this is one vibration. If like this, looks like a rainbow. How many vibrations? This is like half of it, right? This is like half of it. So how many vibrations is this? This is like 0.5. Okay, so if you look at this one, the wave, one complete wave is one vibration. So if the wave just stops here, meaning that this is like just half, so it's 0.5. Okay, 0.5 vibrations. So this is the first part here is 1, and here at the back is 0.5. So 1 plus 0.5, you get 1.5 vibrations. Okay, 1.5 vibrations. This tree represents time, right? If you look at the x-axis, is the time axis, right? So whatever number written on the x-axis represents the time, meaning that this wave takes 3 seconds. Okay, this 1.5 vibrations takes 3 seconds to vibrate. So you 1.5 divided by 3. Okay, 1.5 divided by 3, you get what? 1/2. 1/2 is 0.5, right? So 0.5 hertz. Okay, 0.5 hertz means only half a vibration in 1 second. Can you check whether it's true or not? This one means half a vibration in 1 second. So if you split the graph into 1 second and 1 second, 1 second, like this. Here, look at my pink line. Okay, let me draw it clearly. Sorry about that. Let me draw it clearly. If you split this, looks like this, right? The wave. Now, here is 3 seconds, right? So you split it here and here. This is like 1 second, 1 second, and here also 1 second. So it total up 3 seconds, right? So 0.5, half a vibration in 1 second. Is it correct? Yes, it's correct, right? If you look at only 1 second, this is only half a vibration. This one here. Okay, the next second also half a vibration. The next second, half a vibration. Okay, now how about this one? How about this graph here? 1, 2, like this. How many vibration is this? Just imagine one vibration. One vibration is like one complete, like from here until here, right? This is one vibration. So if I just remove the last section, this one, I just remove this one. How many vibrations it becomes? Okay, you separate it into 4 sections. What do I mean by that? Let's say I can cut it like this. This. Okay, section A, section B, section C, and section D. All these sections, they are equal size, just like your pizza. Pizza, you separate into 4 slices, equal size, A, B, C, D. Okay, so all this section is equal size, and all these add up to 1. Right? So if I remove D, how many vibration? This is like 3/4, right? It's like 3/4, just like you remove the pizza 1 slice. It left 3/4. So 3/4 is equals to what? In decimal. 0.75. So this is 0.75 vibration. Okay, this wave, if it stops here, it stops at this quadrant, this section here. then it only represents 0.75 vibration. Understand? Is that confusing? No? All right. Now look at the right diagram. Okay, almost finished. Just for a few more minutes. The diagram on the right. Now the diagram on the right, I've drawn two waves. One is green wave and another one is blue wave. Which one has a higher frequency? Just by looking at it, you can tell. Which one has higher frequency? Look at the blue line. Blue line is only one. You see, both of the lines they are ending at the same time, right? They are ending at the same spot here, meaning that they are ending at the same time, right? Because your x-axis is time axis. Okay, so if they are ending at the same time, how many vibration does the blue wave have? How many vibration does the blue wave have? One, only one. The green one, like there's several, right? There are three vibrations. So straight away you can see that, okay, the green one has a higher frequency. Okay, green one has higher frequency. Higher frequency wave, it looks like very close to each other, like this. For example, this one is very high frequency. Almost looks like a heartbeat, right? Very close to each other. Low frequency, very far from each other.
Teacher,
Yeah.
is the frequency equals no of